Oscillations can travel through a medium such as air or water without carrying matter along with them. These mechanical disturbances are called waves.
In any era, there are certain experiments which are just barely possible. These are experiments at the state of the art. They're a test of the skill and ingenuity of the very finest experimental physicists. An example today might be the attempt to detect gravity waves coming from distant stars. At the end of the 17th century, a state-of-the-art experiment was to measure the speed of sound. Sound normally comes to us through the air. If there were no air in this room, you wouldn't be able to hear me speaking. Of course, if there were no air in this room, you would have more serious problems, but that's another story. Sound travels very fast, but its speed is not infinite. We can tell that it takes some time because we can hear echoes, for example, sound reflecting from distant walls. And also, we can see lightning before we hear thunder because light travels much faster than sound. 300 years ago, one of those who tried to measure the speed of sound was Isaac Newton himself. His measurement was not the very best in his own era. Experimental physics is a special art, and it was not Newton's strong point. But of course, he was very clever, and it's interesting to see how he tried to make the measurement. At Trinity College, where he lived and worked, there was a long corridor that was known to have an echo. And he tried to measure the amount of time that it took for sound to get down the corridor and return. As a timing device, he used a simple pendulum. Now, you remember that the time it takes for a pendulum to make one full swing depends on its length. He arranged for a sharp noise to go off at just the moment that the pendulum was released. If the pendulum returned before the sound, it was too fast and had to be made longer. If the sound returned first, the pendulum was too slow and had to be made shorter. And in that way, he could get closer and closer to the exact amount of time that it took the sound to go down the corridor and come back, and thereby measure the speed of sound. Today, I would like to give you an intuitive understanding of what sound is. Sound is a wave, a disturbance that travels at a definite speed, like the waves in this machine.